So now in the last video we used an NPN bipolar junction transistor and a Trimpot. We had the NPN bipolar junction transistor wired as a voltage follower. We still do in this circuit, but we added a PNP transistor as well. But in case we lowered the Trimpot voltage enough, the LED turned off, and we raised it enough, the LED got relatively bright. We're using 12 volts, but a 1000 ohm resistor to limit the current. So we're not going to get a ton of current. So I'll set this about halfway. Right there. So we got about 6 volts at the Trimpot. Now, we should have about 6 volts across the LED. But when we were just using the NPN bipolar junction transistor alone, we were losing about 0.6 volts. So to get the LED to 6 volts, I had to set the Trimpot to 6.6. Now we should have 6 and 6 over there, because we're also adding a PNP bipolar junction transistor. So just as a quick review, 12 volts across a Trimpot or other potentiometer. You put whatever voltage across it that you want. But in any case, it has a wiper, has a third terminal. If you slide it all the way up, in this case you would have 12 volts. You go all the way down, you would have 0 volts. And halfway, 6 volts. And so on. Whatever range you want. But that's not intended to provide current. Of course, you got resistance there. If it actually has to provide, any amount of actual current, a little bit can trickle through. It will hold a relatively steady voltage. But better to send it to something that doesn't need any current. And bipolar junction transistors hardly need current. So it's not going to be enough to throw it off very much. But in any case, you can send that voltage to the transistor. Now, we looked at the NPN in more detail in the last video. Now we'll look at the PNP. So it has the positive supply trying to pull the voltage up right there. The transistor actually pulls it down, and thus the transistor here has the emitter to base drop right there, but now the drop is in the opposite direction. If you set 6 volts at the Trimpot, you're actually going to get 6.6 volts right there. Remember, with the NPN, if we set 6 volts at the base, we would lose about 0.6 volts. We'd have about 5.4. We have the opposite with the PNP. We get about 6.6 at the output. If we set it to 6, whatever we set the voltage to, it's going to be about 0.6 volts higher, because it's the opposite of the NPN. You can see we got a 10K emitter resistor to the negative supply for the NPN, whereas we have a 10K, and it doesn't have to be 10K, but that's usually what I see, emitter resistor to the positive supply. So they work the same, but polarities are opposite. So it's really good practice to learn an NPN circuit and then make the same circuit with PNP. Once you get kind of good at that, a lot of circuits make a lot more sense. You understand electricity a lot better. So in case, what we got here is, again, I like 6 volts. It's half of the supply voltage. We're going to have 6.6 at this point, but again, it's not providing power. It's just a signal. And then, so that's with the PNP. We set 6. Going to get about 6.6 there, and we're going to get about 6 over here. So 6 and 6, that's the main thing. Bump up and then bump down, and we should have about the same voltage. So of course there's going to be limitations and stuff. This 10K resistor, since we have a load here, we might get away without it, but it's a really good way to get a voltage to the emitter in relationship to ground. When you have semiconductors that drop voltage, it may drift away. It may not realize where ground is, when it comes to like the base and whatnot. So now I got the multimeter, and we'll look at the power supply. This isn't as accurate as a multimeter, but this also isn't just the current going through the LED, which is probably about 4 milliamps of current. We probably got 4 volts across the 1000 ohm resistor, because the LED drops about 2 volts. But we have 10K resistance there, probably a little bit more than a milliamp going through there. And then these 10K resistors, they also let some current go through them. And, not at the full 12 volts, but there's some amount of voltage on it. So they're going to kind of shift depending on what we do. But the main takeaway is, first, we want the Trimpot at 12 volts, because that was the number that I kept saying, and should be, somewhat close. There we go, 6.1. So I'm not going to fiddle with it anymore, and we'll just leave it at 6.1. Just remember 6.1. Now, at the emitter of the PNP, we should have about 6.7, as you can see right there. And then at our output, should be about 6.1 again. And so yeah, maybe off a little bit, but there you can see it's pretty close to 6.1. So we're not getting perfectly exactly what we're getting in. But you know, we're getting pretty close. Far better than being 0.6 volts less right there. So, and we may be able to improve it where we get even better. And now, out of that 6 volts, the LED drops about 2 volts, and thus we got about 4.1 across the current setting resistor, which is 1,000 ohms. So we'll have about 4.1 milliamps of current coming from the positive there through the transistor, the LED, and then the resistor to ground. And so yeah, there's a number of topics here, but we've covered them in recent videos. Again, we did the NPN version in the last video. Now we just cascaded. We took another circuit like this one, only it's with a PNP bipolar junction transistor. And its emitter is in the same spot as the NPN, and so we got to turn it around. So the emitter is on top because it's going to the positive supply instead of the negative. Whatever you can make with NPN, you can make with PNP, but you got to remember polarities are opposite, current's going to go in the opposite direction, and components are going to be on opposite side of the transistor when you basically make the same component. And LEDs, the long lead, the anode always has to be towards the positive supply, short lead, the cathode towards the negative supply. Whether you're working with an NPN or a PNP, you got to remember their polarity as well. So it's a little bit of a challenge taking an NPN circuit and putting a PNP in its place, because you got to rewire things to be the opposite. But again, that's good practice. Once you get good at that, making a lot of other circuits is a lot easier. So in any case, hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.